Hi everyone, my name is Praveen Vanka and welcome to today's video. I'd like to talk to you about transforms, which is a very powerful and critical feature. Transforms allows you to modify Kubernetes resources during a restore. Because the K10 data management tool supports multiple use cases, transforms can be leveraged for application restore, app migration, disaster recovery, or app mobility use cases. It can also be used to test, add, remove, copy, move, or replace specs of a particular Kubernetes resource. Transforms is JSON-based and also accepts regex values. Today, I'd like to show you a quick way to use this feature. We'll review a simple example, and please note that for more complex operations, you can refer to our documentation for additional details. Here's a test cluster with a couple of applications installed, including K10, and I've already loaded the dashboard. On the terminal window to the left, I'd like to run some commands to verify a few items. First, I'd like to use transforms to move a test MySQL application from a node running in one availability zone to another. One thing to note is that the storage class has also been segregated to each zone. So I'd like to determine what zones each of the nodes are in. Then, as you can see, we've also verified that the test MySQL application is running on a node, and that's in zone US West 2B. Now, this is a stateful application with a persistent volume. So what I'd like to do is also confirm that the corresponding volume that is attached to it is also running in the same zone as the application pod. Now that we've confirmed everything, what I'd like to do is go ahead and take a backup of this application to generate a restore point. So we'll go to Applications, the snapshot action for an on-demand op, and with all the default settings, go ahead and invoke a backup. To view its progress, we can go back to the main dashboard and watch for updates under the activity pane. Now that the job is done, we'll go ahead and simulate an outage by coordinating the node on which the application is currently running on. Please note that coordinating is a Kubernetes feature that prevents resources from getting scheduled onto a particular hardware. In this case, any new workload would not be able to spin up on this node that's running in the US West 2B zone. I previously mentioned that storage has also been isolated by zones. So I'd like to create an extra storage class that's only available in another zone. In this example, I've chosen to use US West 2A, where one of the other nodes is currently running. Once this resource has been created, we can go ahead and verify its details. Now, with assumptions that the default storage class GP2 is only available in US West 2B, as well as the node and application are no longer available due to an outage, let's go ahead and restore the sample application to another node running in US West 2A. When you select restore, one of the options is to leverage transform, so we'll go ahead and generate a new transform action. We'll provide a name, select a resource. Specifically, we'll select persistent volume claim so that we can update its value for the storage class. Because there are many, we'll choose the PVC associated to the MySQL app. Under the operation type for transform, we'll go ahead and select replace. we will provide the storage class name path on the left-hand side, and for its value, we'll go ahead and enter the new storage class name. To verify that this operation has been correctly configured, we can go ahead and select test operation, and upon making sure we select the correct YAML, resource YAML, you can go and click the arrow to notice that the value in line 26 has been updated properly. So now that we have the correct settings in Transform, we'll go ahead and add the operation. We'll go ahead and create the transform, and with everything else default, initiate the restore. Similar to all jobs, we can monitor progress under the activity pane in the main landing page. While we wait for the job to complete, I'll quickly explain some of the details regarding the underlying process. K10 automatically creates all required Kubernetes resources for the application to run properly. As such, it's actually creating new volumes, PVs, PVCs, binding them together, creating the application configs, as well as components such as its workloads. It then spins up the application pod, mounts volume into the container, restores the data, and once all of this is done successfully, it will go ahead and report back with a confirmation. Now that the job is done, we can go back to the terminal to verify that a new volume using the specific storage class pertaining to this availability zone has been created. This is a quick example of how to leverage transforms, and hopefully it was simple enough to use. As previously mentioned, there are several uses for transforms with varying range of complexities. As always, thanks for joining me to learn about this feature, and if you have any questions, feel free to review our documentation or reach out to our support team. Thank you.